Now we are discussing Fermi energy level intrinsic semiconductor. Means the position of Fermi energy level in intrinsic semiconductor. So we are taking a temperature T Kelvin. The electron concentration N is equal to hole concentration P in intrinsic semiconductor. We should remember that number of electrons and number of holes in intrinsic semiconductor are same. Number of holes in intrinsic semiconductor, number of electrons in intrinsic semiconductor are same. N is equal to P. Number of electrons in intrinsic semiconductor, number of holes in intrinsic semiconductor, both are same. equal number. So N is equals to P. Now we are taking N is equal to P, we are taking, but already N value we have calculated. 2 into 2 pi me star kBt by h square whole power 3 by 2 e power of minus of Ec minus Ef by kBt. 2 into 2 pi me star kBt by h square whole power 3 by 2 e power of minus Ec minus Ef by kBt is equals to 2 into is a whole concentration figure value. So that is 2 into 2 pi mp star. Here me star, mp, here mp star. kBt as it is. By h square here. Whole power 3 by 2, whole power 3 by 2. So both are, number of electrons, number of holes, both are almost all same, but only e power Ec minus Ef by kBt. Here e power Ef minus Ev by kBt will get it. So both concentrations are equal. That's why we are writing here. But only exponential powers are different. Here e power of Ec minus Ef by kBt. Here e power of Ef minus Ev by kBt. But minus of here. Here also minus of. Here also minus of. Minus of Ec minus Ef by kBt. Here e power of minus Ef minus Ev by kBt. Minus of Ef minus Ev by kBt here. So that difference is there. But another difference is me star here, mp star here. Mass of electron, effective mass of electron, effective mass of proton here. Positive whole. Effective mass of whole we are writing here. So on simplification, both sides, 2 gets cancelled. Here whole power 3 by 2, whole by 3 by 2 both are same. That's why here 2 pi kBt by h square gets cancelled. Here 2 pi kBt h square cancel. Only remains here me star remains here. mp star remains here. So me star whole power 3 by 2 remains this side, and e power of minus of Ec minus Ef by kBt is equals to, here remains mp star whole power 3 by 2 e power of minus of Ef minus Ev by kBt remains here. So that simplification, that value we are going to get it here. Same as it is, just I said we got. So here remaining is me star whole power 3 by 2 remains here. We have written. Remaining all are getting cancelled. 2 gets cancelled. 2 pi gets cancelled. kBt gets cancelled. h square gets cancelled. Only me star whole power 3 by 2 remains here. That you are written here. This is as it is not getting any value here. That is why e power of minus of Ec minus Ef by kBt, e power of Ec minus Ef by kBt as it is writing is equals to. Here also 2 and 2 pi mp and 2 pi kBt by h square is already cancelled on both sides. That is why here remains mp star only. This mp star only remains, that mp star whole power 3 by 2, whole power 3 by 2 remains. Here exponential is not getting cancelled. That's why as it is writing here e power of Ef minus Ev by kBt we are getting. So what we are doing is, this me star we are bringing as a denominator of mp star. This me star we are bringing as a denominator of mp star, and this e power of minus Ef by e power of minus of Ef minus Ev by kBt we are bringing as a denominator of Ec minus Ef by kBt. So if you do so, that we are getting like this. So this value brought here, this value brought here. That's why we are getting e power of EC minus EF by kBt, means this value we have written here. This value is brought here as a denominator of this sum. So EF minus EV by kBt, e power of minus of EF minus EV by kBt written here. So this value we are bringing this side now. So MP star as it is whole power 3 by 2. This ME star value here. This is also having 3 by 2. This is also having 3 by 2. That's why MP star by ME star whole power 3 by 2 are getting. Next. Here this value, if you bring it up, it becomes plus, it becomes minus. So it means denominator you are bringing as numerator. So already numerator, the value is in numerator. So that's why e power of minus EC minus EF by kBt. It's also having kBt. Already this kBt common taken kBt. This EC minus plus EF we are getting, minus EC plus EF we are getting here. So here minus is sent inside, that's why minus EC plus EF we are getting. That minus EC plus EF we got from here to here, kBt as this. Here minus it is comes here, then what happens, this minus gets cancelled. So what remains here, if it even if you bring it here, if you bring it as a denominator, what happens, the same value comes here. So this minus EF plus EV, if you are going to bring this minus inside, minus EF minus into minus plus EV, that we are getting here kBt. So this we are bringing to top of the numerator, nearby the numerator. So we are getting kBt here is LCM is a kBt, that's why we are getting kBt. This EC minus EC plus EF. If you bring it up as a numerator, e power, if you bring it to up, what happens, 1 by e to the power of minus 6 is equals to e to the power of plus 6. So this minus becomes plus 6 if it moves up. The same way, if it is going up, what happens, this minus becomes plus EF, this minus plus EF, EV becomes minus EV. kBt is already LCM is taken. So MP star by ME star whole power 3 by 2, MP star by ME star whole by 3 by 2, we got it. Now what remains here, EF plus EF, 2 EF we are getting, so 2 EF. This kBt I am writing separate to 2 EFs, so by kBt separate. Minus, here minus is here minus, taking common minus here. So what happens here, EV, EC, that EC already, plus minus already taken common, that's why you are getting E plus EV. But both values we are having kBt, that's why we are adding kBt. So two terms we are writing separately by taking minus common. So next, MP star by ME star whole power 3 by 2, MP star by ME star whole power 3 by 2 we are writing as it is. If you take both sides logarithm, what happens? Log e power of x is equal to x. So from this formula, so e to the power of 2 EF by kBt means this EF plus EF, 2 EF by kBt that we have written here, and minus of minus is there, both side taking common here. So minus if you take plus EC, minus if you take common, this becomes plus EV within the bracket by kBt, MP star by ME star whole power 3 by 2 as it is we have done. But both sides we are taking logarithmic on both sides we get according to log e to the power of x is equal to x. According to that formula, log, if you take log e to the power of x, this total value is taken as a x. So log e to the power of x becomes what? X. This x becomes x only here. So 2EF by kBt minus of EC plus EV by kBt, minus of EC plus EV by kBt as this. Means this is totally x. Log e to the power of x is equal to this x only. So x is added. According to this formula, log e to the power of x is equal to x. With that we are writing here. Is equals to log, if you take the power becomes a multiplier. 3 by 2 power is going to become multiplier, natural logarithm mp star by me star, mp star by me star. Why? Because both sides we have taken logarithm. That's why logarithm we got it. Logarithm we got it. Now this value is this value minus EC by EV, minus of EC plus EV by KVT value you have to send that side. Then becomes, this minus becomes plus. So then what happens? 2EF by KVT is equal to, like that you will get it. That you can see this value entire term minus of EC plus EV by KVT we are taking to right side of equation. Then this minus becomes plus. But you can see here the next step. So 2EF by KVT, 2EF by KVT, this value only in right side, left side of equation. So 2EF by KVT, 2EF by KVT is equals to this value. This value is taken that side. So like this here, when you are taking this value that side, what happens? It becomes plus. That is why plus EC plus EV by KVT plus 3 by 2 natural logarithm MP star by ME star. This value as it is 3 by 2 natural logarithm MP by ME star. That is we have done here. Right, now from here to here, what are doing? 2EF by KVT. 2 by KVT is sending that side. Then what happens? EF remains, EF remains. 2 by KVT, if you send that side, what happens? EC plus EV by KVT into KVT. It becomes like this. You can see here in these notes. So 2EF by KT or KVT, this KT you are sending, 2 value you are sending. So EF, this 2 by KT is then that side. So 3 by 2, 3 by 2. This KT is coming here. This 2 is coming by 2. Logarithm. MP star by MP star by ME star, MP star by ME star. Plus this KT has come here. And 2 also comes here into EC plus EV by KT, EC plus EV by KT. This KT cancel, but 2 remains. So final term you are going to get it like this. Here EC plus EV by 2 remains, that I am writing here, EC plus EV by 2 plus 3 by 2 into 2. 3 by 4, 3 by 4. Here KT, 3 by 2 into 2, 3 by 4. So like this you are getting 3 by 4 KT logarithm of MP star by ME star. Like this you are getting. So 3 by 4 KT logarithm of MP star by ME star. So here we are getting like this. If we apply the condition t is equal to 0, then what happens? EF is equals to t is equal to 0 means 0 into something 0, 0 into something 0. So total term is going to vanish. Then EF is equal to EC plus EV by 2 only remains. This means Fermi energy level lies in between the conduction band and valency band of energy gap. So you can see the figure. If you draw a figure like this, it is conduction band, it is valency band, then it is EC, it is EV. This is called energy gap. So this is a Fermi energy level. EF is equal to EC plus EV by 2. They are present. when T is equal to 0, this is going to happen, means the Fermi energy level lies in between valency band and conduction band. Middle position is going to be present, means exactly middle of energy gap. That we can see here also, the same diagram, EC, EV. So EF is equal to EC plus EV by 2 when it happens, then when T is equal to 0 it happens, then Fermi energy level lies in between the conduction band and valency band, exactly middle of energy gap. But according to this equation, just we got this equation, EF value. According to this equation, if T is set, T is not equal to 0, if T is not equals to 0, at that condition, what happens? As temperature increases, T increases. As T increases, what happens? The Fermi energy level moves in upward direction. The Fermi energy level moves in upward direction towards conduction band. See, Fermi energy level middle to rise to nearby conduction band. From this figure to this figure, if you compare, when T is equal to not equal to 0 and T increases, the Fermi energy level moving from middle to top. This is about explanation of Fermi energy level motion in between conduction band and valency band.